Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
polymers, polymerization and polymer strength. So polymers are large molecules that are made out of smaller ones. So smaller molecules are called monomers. So lots of monomers will go and make up a polymer. So polymers are made by chemical reactions that join them together. So for example, a molecule of polyethylene is made out of thousands of ethene molecules joined together. Long molecules like these give polymers their properties. You can get natural polymers, so things like silk hair proteins, and synthetic, so man-made polymers, so things like polythene and polyethylene, styrofoam, things like that. So polymers made in a reaction that goes and breaks open the double bond in alkenes. So ethene is an alkene with the formula C2H4, so the double bond makes it reactive. The ethene is heated and the double bond is broken open. Another ethene monomer bonds to the first one, so the polymer chain grows as more ethene monomers bond together. So the polymerization reaction continues until polyethylene is formed. So polyethylene and polymers are found just about everywhere. If we're looking at drawing polymers, we start off with the monomer. You open up the double bond, put brackets around it and put a little N on the right hand side to show that there are a number of that particular monomer that are joined together. So if we're thinking about the process used to make polystyrene, it's going to be polymerization. The compounds of hydrogen and carbon in crude oil are called alkenes because they're what are bonding together. And if we are looking at describing how this addition polymerization occurs, key things to talk about is that we've got many monomers which join and link together because the double bond breaks open. Different polymers have different properties depending on the particular monomers that they are made out of. So this gives them different strengths. So polymer fibers can be used to make firefighter uniforms. So the table below gives some properties of two polymer fibers. If we're looking at evaluating the suitability of each, so some of the key things that you'd have to talk about is that the advantages of polyester, so it's better flame resistant, it has a higher melting point, it absorbs less water, it absorbs water, so it's less likely to ignite. Disadvantages is that it's heavy because it's relatively dense. Because it absorbs water, that makes it heavier, and such forth. Some polymer chains have side branches, so low density polyethylene is something like this. So the material has a low density than high density polyethylene. The forces of attraction between the polymer molecules are relatively weak, and the material is less strong and has a lower melting point. High density polyethylene, so the material has a higher density than low density polyethylene. The forces of attraction between the polymer molecules are relatively strong, so the molecule is stronger and has a higher melting point. So high density polyethylene does not have that many side branches. Thermosoftening plastics are plastics that when they're heated up can be reshaped. So we're thinking about thermosoftening polymers can be used to make plastic bottles or food packaging. Why are thermosoftening polymers not suitable for storing hot food? It's because they would melt as they have a low melting point. Thermosetting polymers are made out of polymer chains that are held together by cross-links, and this means that they don't melt when heated. So a thermosetting polymer is used to hold dental braces onto the teeth. How can you tell from the diagram that the polymer is thermosetting? So the key thing that you need to talk about is that the chains of monomers are held together by cross-links.
thanks for watching.